Shift control negative. Is that what you said, Cabrillo?
Yeah.
I just need to read. Okay, I want to first go to the taping, what you're going to do this weekend. You're doing taping and leveling. So let me remind you about the taping. Or you guys tell me, what are you doing in the taping? What's the first thing you're doing? You're going to create a triangle. So you're going to put in 3 guineas, right? You know what guineas are. One's going to be A, B, and C. How are you going to arrange A, B, and C? Clockwise. And then you're going to tape from A to B and B to A. Right? Remember? You're going to create a triangle by setting up 3 monuments labeled A, B, and C, and they're all going to be clockwise. And when you set that up, remember one of the sides of the triangle must be greater than 100 feet, or one of the sides of the triangle must have enough of a grade change that you have to break tape. So basically, what do I want you to do? I want you to come up, be comfortable breaking tape, measuring and then measuring again. Then 2, you tape line A, B forward to the nearest thousandths of a foot. And what you do is you lay the tape on the ground, just like you did today in the pacing. You lay the tape out. Okay, you don't measure with it still on the spool because you could break it. You won't break tape the right way, you'll break the tape the wrong way. Break the tape. Get it? Okay, so you lay it out on the ground, you lift the tape up, you use the plumb bobs over the guineas, put the tension on it, you make sure that you're using the hand level and you measure it. So, do you remember that you are only allowed a certain error, right? 1 in 1,000, do you remember that? For every 1,000 feet you measure, you could only have a maximum of 1 foot error. So, and do you remember what that is? Is that accuracy or precision? It's precision because you're measuring one way and measuring the other way. You're comparing the 2 values to each other. So remember we looked at the calculation here? Remember we did it like this? So here's AB. They measured it forward and got 87.22, and they measured it back and got 87.22, and the average is 87.22. Precision, it's exactly the same. There's no error at all in the precision, because they got the same values. BC is the same, but let's look at CD again. We looked at it last week. They measured forward, they measured 100 feet, and then 2118, so it was 121.18. Back, they measured 121.21, 121. The average of these 2 numbers is 121.20. Isn't the average really 121.195? Yes, but you can only carry it out 2 decimal places and you bring it to the nearest even. So they got a precision of 1 foot error in 4,000 feet. Is that okay? How come? It's a smaller error than the 1 in 1,000. If they got an error of 1 in 400 feet, what would happen? Too big an error. Do it over. Just do it over right then and there. Okay? You don't have to you don't cross any of these out because they were all things you measured. Your next line would just be CD again, the second time. Okay, so tell me this. Let's say your survey crew goes out there and you measure AB, BC, CA, and then you go backwards. Is that a good way of doing it? No, why not? If you're making errors, you want to catch it at the beginning. Measure AB, BA, and check. If you have no errors, you're doing good and you don't have any problems. Then you go BC, CB, and check your error again, and then CA and AC and check your error. But if you went all around, it's quite likely that you might not do a good job the first time, right? So let's get the kinks out before you go into the next one. So do A, B, and BA and check it. Don't go all the way around and then all the way back because you might have errors galore. Everybody good? Okay, so you're taping that triangle, and then you're checking to make sure the precision is okay. And then there's some,
how do you figure out the precision of the tape?
oh, so here's the equation. We looked at it last time.
Oh, okay.
So it's the experimental, or I should probably say measured value 1 minus measured value 2 divided by the average. So it was 121.18 minus 121.21. Notice it's absolute value, it's positive. Divided by 121.20, you get this long number, and then you hit that reciprocal button on your calculator. It's right there. Okay. And then there's another calculation too that you have to do for our angles, but it's telling you exactly what the formula is. We don't need to go over that. Okay. So now let's go to the differential leveling. So here, you're going to determine the elevation of the 3 corners of the triangle that you did. So the triangle you set up for taping is the same triangle. Okay. I'm getting a little thirsty, so I'm thinking of make sure you bring water out in the field. It's been hot out. Wear hats, bring sunscreen, bring enough food. Make sure you're comfortable. You know, make sure you bring layers so you can take clothes off in the afternoon when it gets really hot. Make sure you're prepared physically for it. Okay. Okay. To determine the elevations of the 3 corners, in order to adjust the elevation, why would I put a note here? Does it mean that it's important? Yes. Many people come back from out in the field and they forgot to do what I said there. In order to adjust the elevations at the end, you will need to measure the horizontal distance from the benchmark to point A and point C to the benchmark. Let's take a look at what the picture looks like. Now, notice this is exactly how you're setting up your field book. Exactly. Titles on the top, weather, date, here the equipment number, people's names. There should be a signature down here. Yep, there's a signature. Here are all the calculations. Here's a drawing. In this case, though, they had 4 points, A, B, C, and D. We only did 3 points. And this little Y here is the symbol for the tripod. And notice there's a north arrow, right? You have to make sure you have a north arrow. So let's look at, I did it in the example, they didn't put spaces between, and I find I'm more comfortable when there's a line in between. That's why I had you create a line, and I would do it too, so I crossed it out. So here, we're starting with benchmark X, and they go A, B, C, D, A. So which elevation do we know? We know this one, right? You start out with knowing 98.424 is the elevation of the benchmark. And here's the back sight, right? So you take this number and you add it to the back sight and you get the height of instrument. Then the height of instrument from the foresight gives you the new elevation at that point. So let's do it like we did. You can draw circles around it if you'd like. You could draw this on your sheet. This is setup 1. This is 1. Setup 2. Setup 3, setup 4, setup 5. They did 5 setups. We're not going to have that many. All right, elevation plus the back sight gives you the height of instrument, minus the foresight gives you the elevation. Elevation from the back sight plus the back sight gives you the height of instrument minus the foresight gives you the elevation. so let's look at the,
What is the point of having multiple setups?
because, good point. So, if let's say all you are in one, are places on the earth that I have to survey, and the benchmark's over there. I could just cite the benchmark and then cite Ruby, do a backside on the benchmark, do a foresight on Ruby and find her elevation. And then I could do a foresight on Peter and find his elevation. And I could do a foresight on Tristan and find his elevation. It's one setup. But part of this class is for you to get comfortable using the equipment. And a big part of it is getting the tripods level with the equipment level. And it takes time at the beginning of the semester. At the end, you're gonna be a pro on it and bring it up really fast. But I want you to get more experience setting up. Okay, so that's why. But 2/3 through the semester, when we get to the topo lab, you're gonna be citing one benchmark and you're gonna just shoot all these points. But for now, we're doing setups, because I wanna make sure that people get comfortable doing the setups.
And on the drawings, do you want those to scale, or is it just a scale?
No, you don't have to do it to scale. Just put NTS, right, not to scale. Okay. So it says locate the nearest benchmark, so Kelly will show you where the benchmark is. Choose a point, a position approximately equidistant between the benchmark and point A, ensuring that the rod placed at both points would be visible from your position. This will be the location for setup 1. If you set up your equipment without thinking where the point is and then a tree is in the way, you can't cut the tree down. You have to set up again. So make sure that when you set up between 2 points, you can see those points. And if point A is the door and point B is this door, I usually don't set up in the middle of both of them because I gotta keep turning. I would probably set up here so that I could see both points. I wanna be able to see them both. Okay, rather than having to turn 180 degrees. It's just kind of what's common. Okay, so you're gonna choose a point equidistant between the benchmark and point A, ensuring that the rod placed in both points would be visible. You also have to make sure that you're not too high or too low. You probably noticed on the rod there was a little a round thing that you could screw and lock. You could actually raise the rod up, but you have to make sure it raises and clicks. So it's better not to be too much of a grade change where you set up. You want to be able to see both points. Be able to read. Set up your tripod without the level so that the plate is, the flat part on top is approximately horizontal. And use a carpenter's level if you like. So we're going to take out a tripod. Should we take one out now? Or remember Patrick had one out the other day? All right, so it has 3 legs. And then there's a plate on the top. If the plate's like this, it's going to be a pain in the ass to level the level. Okay, so you want to get it approximately flat. And a lot of students in the past would like to take one of those carpenter's level out. You know, so get it kind of, then you take the level out of its case and you put it on and you screw it in. Okay, and we're going to look at that today. We're going to look at the level. Patrick, would you mind getting some levels out?
Sure.
So it has a bullseye level. So I'm going to show you how to turn the bolts, turn the screws to get it leveled. So once it's leveled, you're set. Take a backside on point A, calculate height of instrument, foresight on B, height of instrument. I'm sorry, foresight on point B, and then find the elevation of B. Then you take your equipment and you move it now. So let's take a look at the picture. F, let's do it on here. Can you see this is far away? Should I move it or you're okay? I'll draw big. This is my benchmark, right? And here's point A, B, and C. A, B, and C. So here's my triangle. first setup, where do you wanna be? You wanna be between which 2 points? First setup. You gotta come from the benchmark, right? Because the benchmark is the point of known elevation. So your first setup is here. Setup 1. I'll just call it S1. Setup 1, you're gonna take a back sight to the benchmark. BS, back sight. And then you're gonna take a foresight to A. That's your first setup. And you calculate your elevation in A. Then what do you wanna do? You move your equipment between where? A and B. Setup 3. Oh, 2. Do the back side on A, right? And a foresight on B. Then what do you do?
Between B and C.
Then go between B and C. Setup 3. Back sight to B. Foresight to C. So you started with an elevation of the benchmark. By setup 1, what did you find the elevation of? A. Setup 2, you found the elevation of B. From setup 3, you found the elevation of C. You just found the elevation of every single point. But what if you incurred a big error here? We have to check it somehow, right? So what are we going to check it to? Go back to the back sight. So we have setup 4. You take a back sight to C and a foresight to the benchmark. And we should get the same elevation with the benchmark elevation that we started, right? Okay, everybody good? Okay. I will, when we have the levels, I'll show you how to level them. Okay, then it says, there's a thing here that's really important. Look at number 7. Put a circle around number 7. I think, yeah, get 4, get more. Just bring out a whole bunch. So number 7 says, you know, have you all looked through a telescope before, or binoculars, right? Or maybe even a gun has it, I don't know. But you see crosshairs, right? And if you turn it, the picture, there are two focusing knobs on most telescopes. One is to get the crosshairs focused, and one is to focus on the distant object. You need to make sure that they're both focused. You need to make sure the crosshairs are focused, and you need to make sure the distant object is focused. Because then they're on the same plane. If one's focused and one's not, you actually could incur error. It's called parallax. So it says, focus the telescope on a distant object, and then focus the eyepiece so the crosshairs appear sharp and distinct. If the object appears blurry, refocus the telescope and then adjust. And the way to check is move your eye, just look at what I'm doing. Move your eye slightly side to side and up to down. And if the crosshairs are jumping relative to the object, it means that there's parallax going on. So you have to make sure that that's okay. So just be sure. Again, you want to make sure that you're detailed because you don't want to do the lab over. Okay? Okay, so I want to read this asterisk here. If there is a significant grade change in the area that you are surveying, you may not be able to read the rod at both points that you are sighting. Does that make sense? If I set up my instrument and one point is really low and one point's really high, I might not be able to sight the rod, even if I extend the rod. If there's a grade change that's bigger than the rod, I'm not gonna be able to read the rod. So you might have to have an intermediate point. You might have to have another point. Let's say you're going from the benchmark to A. Can I change this here? Let's say you're going from the benchmark to point A, and you're so far away from A, and there's such a big grade change that you actually have to put an intermediate point, and we would call that a turning point, just like we used that turning point before. And you would have one set up here, and you would do a back sight, and then a foresight, and then you would have to move your equipment again and do a back sight and a foresight. So there might be you might be in a situation where you're actually have to put an extra point in. It's so hard to be, it's so late, hang on a second. Just think about everything ahead of time. Before, don't just go out there and slam in the guineas and say, okay, let's get this done. Think about it. You have to be able to find the benchmark, and you have to be able to find point A. Set it up in a spot so you don't have to do a turning point. Find out from Kelly before you leave the lab, the office on Saturday, where is the benchmark? Because you're gonna tape first, right? But you're gonna put the 3 guineas in and make your triangle with the taping. You don't need to know where that benchmark is yet until the second lab, and you're using the same triangle. So ask Kelly, where is the benchmark? And then set up a place where you don't need a turning point. You have to think ahead. Does that make sense? Is it a big deal if you have a turning point? No, you just got more practice. You want to be proficient, right? The most important thing, maybe the most important reason you're taking this class is because you have to take it to transfer, okay? But let's think about it. You're an engineer and they throw you on a job site and they tell you to survey, which they did to me. I had to go out and survey. I was like, well, where are the licensed surveyors? I had to survey. Luckily, I had a surveying job when I was in college. But I had to go out and survey. The more important thing is to be able to know how to do it, So getting out of a turning point, Saturday, having a 6-hour Saturday lab, being there 8 or 9 hours maybe is the worst for you, because you don't want to be there on a Saturday, but worse would be not learning how to use the equipment. To say that you took a course and you don't know how to use the stuff. And all the equipment is the same. Patrick put out a whole bunch of levels. We have a million different kinds of levels. All the theodolites and the total stations are exactly the same, but all the machines are the same. If you get a different company's total station, you just have to know which button. Oh, where's that button? Oh, there it is. And I'm so proficient with this now, I know where the buttons are gonna be. They're on the left side in the bottom, or the left side, right side on the top. So you just have to it's important. So, whatever. Make sure you're touching the equipment, make sure that you're using it. Don't let somebody use it who knows how to use it already and you can get through the lab fast. You gotta learn this stuff. Okay, so do you understand why you would do a turning point? You might have to. There's a zillion trees in the way. There's no way you could do it. Yeah.
So if you put in the extra turning point, do you have to include that in your field notes?
Yes, you do. Yeah, you can't bypass it. Remember, the field notes are legal documents. It's gotta show exactly what you did. You can't say to a judge, oh, well, there was another spot, but I just added it in my head. It's not gonna work. It's like, you're out of there. So in this case, this is really setup 1, right? This is setup 2. This is setup 3. Setup 4. You know what I'm doing, right? You're working as you go along. Don't try to start writing everything in the field book. Write as you go along, because you might need another line.
Will it be apparent if there's a significant grade change, or are we gonna figure that out after we do the first thing?
Well, remember with the triangle, you have to have either a significant grade change, you have to break tape. So you either need a significant grade change or over 100 feet. Maybe do over 100 feet, so there's not a significant grade change. But there could be a significant grade change from the benchmark depending where you're located and where the closest benchmark is.
Yeah.
So, ask your question again, Lena.
grade change from the benchmark to our first point, is it gonna be apparent whether the grade change is significant or not?
You mean, is it gonna be higher than the rod?
Yeah, are we gonna
Right.
be able to just like see that?
No, and your eyes will be, your eyes are messed up. I mean, you remember that one video we watched last week where the person said, oh, you can tell by eye? No, you could be off 10, no, not 10 feet, that's ridiculous. You could be off a few feet. Your eye is not, it would be nice if we had a little bubble in our eyes to like get us level, but we're not. So what might be helpful is bring out one of those hand levels, and you're gonna have it for the taping. Bring one of those hand levels, because by the time you set up your instrument and everything and then you're off, you're like, shit. You know, bring the hand level and then you could approximate whether you're gonna be off or not. Right? So one person holds the hand level and one person has the rod and say, oh yeah, I could see that number, you know. It's not over. So it's not, I mean, if it's really, a really huge grade change, then yes, it's apparent. Like if you're going up the slope here, up to the top, yes.
You better believe it.
But where you are, you won't notice. Well, you'll see the,
Is there a designated spot that we're
no,
gonna?
you could be anywhere you want, anywhere on campus. Typically, we're around the library, like so on the amphitheater or in front of the library. You could be anywhere you want. It's just Patrick and Kelly need to find you unless you don't want them to help. You know.
And if we're doing it on a different day, how are we gonna check out equipment?
That we could work out some other time. The more important thing is you need to know where the benchmark is. Okay. So who's not coming Saturday? Strider, you're not. David is not. Is it just the two of you?
I'm not sure yet, but I might not be able to make it.
Okay, did you write your name on that list or no? Yeah? So Strider, did you have both David and Jay?
What do you mean?
Who wasn't coming?
I didn't know about Jay. Mason was not going to, but now he can, so.
Okay, and Mason couldn't come today. All right, so Jay, could you, so it would be,
Okay.
a group of two doing taping is difficult, so if you can't come, then it might be good.
All right.
Three of you, your choice.
No shows on mine.
Okay, let me keep going. So, there,
Quick question.
yeah.
Because we're using the guineas and they have to pound in the ground, you at least have to put all of your triangular points somewhere where you can pound in the ground, correct?
Yes.
So yeah, no comment.
We could do something else, like on asphalt, you could put a nail in. It's not a problem. Concrete, you can't put a nail in. You could scratch it, but it is kind of hard to set up a tripod on concrete. You know, it could damage the equipment, it could slide.
No,
We do have this thing, but we only have one of them.
no, I think that's fine. I was just curious.
Yeah. But even if a turning point is on concrete, you could still set up your tripod on dirt or grass, because you could be, you guys are not setting up your tripod over points, right? We're away from, we're shooting points, we're not setting up on points. So now let's look at the amount of error. Okay. So you should, this is the computation. You should have computed the elevations of point A, B, C, and the final elevation of the benchmark as you went along. The final elevation of the benchmark obtained by completing the circuit should agree with the initial elevation within 0.010 radical n, where n is the number of setups. So in this particular case, that we had to put a turning point in, how many setups do we have now? 1, 2, 3, 4, 5 setups. So what is 0.01 times radical 5? Do the count, someone do a count. .022. Okay, and what if it was only 4 setups? Oh, that's easy, 0.02, right? 0.02. So if we look at, so that means that you know what the elevation of benchmark is, right? Everybody with me? You go all the way around the circle and circuit, or a traverse, and you get the new elevation, the benchmark. The difference between the original benchmark elevation and the new benchmark elevation should be less than this. Okay, if it's not, you didn't have allowable error, and you had more error than you should have. Okay, so what happens in that case? Then you're gonna get 2 points taken off the lab, but you can make it up or redo it then. I think it's very hard to like get your crew back out in the field to do it. I probably would do it then.
You said it should be less, like the difference?
This is the allowable error, meaning that this is the max.
Okay,
This is the maximum error.
okay.
Okay, it's the maximum error. And then even if you have, I'm gonna let Kelly explain this part. When you go back to the office after your error is okay, you're gonna distribute your error. So let's take a look. Again, this example is different than what you're doing because they did 4 and they didn't come back to the benchmark. Look what they did. This is ridiculous. Look at this. This isn't a group. This is another faculty's work from another lab. Look, they started at the benchmark. They did a setup 1, down to elevation A, setup 2, elevation of B, setup 3, elevation of C, setup 4, elevation D, setup 5, back to A. They never checked their elevation at the benchmark. So if they made this huge, super duper error right here, in setup 1, between benchmark X and A, and then they came around, they'd never know, but all these would be wrong. You can't check your work by coming back to a point that you found the elevation to. You have to go back to a benchmark. That's why this example is good. It goes back to a benchmark, or that example we saw in our notes where they went from one benchmark to another. Does everybody understand? You have to go back to a benchmark. But let's just use what they're doing. Look, they got an elevation of 100. When they came back, they got an elevation of 100.07. So what's the difference here? What's the error? 0.007. Is it within the allowable error? Yeah, it's less than the 0.02 or whatever, 0.022, whatever you guys found out. And then there's a way of adjusting the elevation at the end because you want to distribute the error. And here's the way, the calculations, but I'll have Kelly show you that when you come back in the office. So you're gonna go out in the field, you're gonna do the taping, you're gonna do the leveling, you're gonna have your lunch out there, and then you're gonna, after you finish both, you're gonna come back in the office, and that's when she'll explain how to do this correction. Because this correction right here is not critical in terms of what you're doing out in the field. Kalika?
So back on the other page, instead of A after D, it should have been the benchmark.
They should have came back to the benchmark.
Okay.
They should have went from D to the benchmark, just like we're doing benchmark A, B, C back to the benchmark.
Okay. So that A shouldn't even be there.
Yeah. Right,
Should be
but
different.
you know what I probably should do is I should take the sheet, I should cross this out, put a benchmark, and then come up with better numbers so that we're close to here. Because it can't be 100, right? Otherwise they're off 2 feet or a foot and a half. So that I should change that. Okay, but one thing, remember the note I said? Remember I said the note, in order to adjust the elevations at the end, you need to measure the horizontal distance from the benchmark to A and from point C to the benchmark. But you do not have to do it like you do taping, where you have to hold it and put the load and be over the plumb bob. It's an approximate. Just go out there with the tape and measure it and be done. But you just need to know the distance. And the reason why is the belief is that the longer the distance, the more error you made. So they want to have everything corrected based on distances. So everybody's going to remember to just run the tape from the benchmark to A and the benchmark to C. So, the surveying lecture used to be taught on Wednesday, and we wound up changing it, one, for scheduling issues, but two, to give you more time to prepare for lab. Today's Monday. Tuesday, Wednesday, Thursday, Friday, you have 4 days to prepare before you go out in the field. So what do you think would be good to prepare?
Write down.
Do your leveling homework. Do the homework that's due next Monday on leveling. For 2 reasons. One, you'll be comfortable with leveling right before you go out in the field. You also are studying for the test because the exam is next Monday, right? So you do your homework from now to Saturday, and you could ask Kelly questions or Patrick questions. So do the leveling homework.
Oh no, just saying hi, cause.
Yeah. So do the leveling homework before Saturday. Look at your notes in taping too. I mean, you have to be prepared, but I gave you your homework back. Do you remember what the, do I check your answers for your homework? No. That's all I'm doing is I'm grading the homeworks based on completeness and how the presentation. Okay, so what should you do? You should look at your homeworks, and we gave you back the leveling homework, the taping homework today, the one you just turned in, so that you have your homeworks. Look at the solutions. I emailed you all the solutions to the homework, so you have it. I'm really sorry that Patrick and I did not post the video from lecture last week. I mean, posting it now is useless for us. I mean, the whole idea of having lecture is so that you could watch it again if you're confused with things. So I really apologize. But Patrick, we're gonna get this posted, right?
Right.
Like tonight. We'll see.
Yeah.
Or tomorrow. Or tomorrow, the latest.
I've been looking into that, yeah.
Okay. So, we wanna put it on YouTube.
I would still post the first one.
It's already up.
Oh, it is?
Well, it's up, but I don't know where it is. You gotta tell me where it is. So,
Because that would be good for the exam.
for the exam, okay. Yeah. So we'll post them. So let's say by 12:30 tomorrow, are you in the STEM center from 12:30 to 2 tomorrow? It's after physics?
I have lecture from, I have Chem 1A at that time.
Between 12:30 and 2?
Yeah.
Okay. All right, well, that's where.
Tomorrow's my busiest day.
Oh, really?
And, yeah.
All right, we'll
What-
talk after this.
Yeah.
So I would do, compare your taping homework to my solutions that you have. I'll send you the solutions. I'll actually email you the leveling solutions tonight too. I'll email it to you before it gets posted, because I can't post things from my office yet. But you just have to really be prepared. So there's only one more thing that I need to show you, and this is still really important. So I want to go back to something. And I'm going to go back to the lecture packet.
If you just type in engineering 1A, it shows up. It's like,
On YouTube?
yeah. It's like the 5th one down. 6th one down.
Okay, remember this problem? Right, so I'm just gonna draw the last line. What does the elevation of benchmark 2 come out to be? 1 what? 121.09?
120.
120. So this is differential leveling, right? You took the elevations and you added the back sight, right? And then you got the height of instrument, and then the height of instrument, and you minus the foresight, and you got the new elevation, right? So in a way, you took the elevation, you added the back sights, you subtracted the foresights, and you got the new elevation. So isn't the back sight minus the foresight equal to the change in elevation? If I sum up all the back sights, and I sum up all the foresights. Let's do this. 11, 0, 8, 9, 17, 24. Five, carry the 11, 12.
25.
Do you have, is this what you have?
I got 25 even, but I probably,
Did you get the same numbers or no?
for BS, I got 25 even.
Okay, so what's the difference between the back sight and the foresight? This is really important, you guys, I'm sure it'll be on the exam. What's the difference?
12.7.
12.75, right? This is the difference between the back sights and the foresights? What's the difference here in elevation? It should be the same. Okay, so the difference between the back sights minus the foresights, absolute value, is equal to the change in the elevation. This is critical. But what does this mean? That's all it means is you're checking your math. You're not checking the surveying. That's all it means is that at the end of doing this whole table, if you add up all the back sights, add up the foresights, subtract them, and they're equal to the change in elevation, all the math in this table is correct. If they don't equal each other, it means you made a math mistake. A math mistake. So if you know now, this is really only to check your math. How do you check your surveying? What did we just look at where we were able to check your surveying? We looked at this. This is where you check your surveying. This is where you check your surveying because this is the maximum error. Okay. So, you know what I'm gonna do? I'm gonna make up a study sheet for you guys for your exam. Because I was hoping to do a review and we don't have time. So I'll make up a study sheet of all the things, all the topics. I had that in my materials class when I did materials. I feel like there's not a lot of stuff. There's not a lot of stuff, so you really have to know it all. Because maybe there's 10 things you need to know. And I'm gonna test you on all 10 of those things because that's all there is to test. It's not like there's 20 things and I'm only gonna test you on 10. It's like there's really just, so I'll make up a study sheet. Okay? All right, so Patrick, you said just do a search on YouTube for Engineering 1A.
Yeah, honestly, if you search it all, the name of the video is Engineering 1A, Class
And is
1,
it-
Fall
is it-
2016.
Is it ENGR 1A or Engineering all the way out?
Engineering all the way spelled out.
Engineering spelled out 1A,
Yeah,
and it has it on YouTube.
yeah. And I put a bunch of tags, so you can put Cabrillo, Engineering, Civil Engineering, it should come up, you know.
Okay.
And it's like, yeah,
Okay.
it's very searchable.
Okay, so I wanna put a link to it on the webpage.
Okay, you want to do that now, or?
No, send me the link and I'll have to do it tomorrow.
Right.
It's like, Saturday, you here with South.
Yeah, Saturday you meet here at, you guys, 9:30 is when lab starts, the field lab, so I would show up a little bit early for that. And, she and I will set up the crews, cause, it's really important that at least one person knows how to do AutoCAD, and, you know, from our experience, it's been helpful when we figured out who's working with who. Okay. All right, have a good night.
9:30.